does not look like a transmission. This is actually out of a Jaguar XKE independent rear. This is the center section. This is where the ring and pinion are housed in. This is a Dana 44 center section. And the Dana 44 center sections were used in a wide variety of applications, from Corvettes to Jeeps, different types of moped applications, truck applications. It's a very durable ring and pinion set and carrier assembly inside of here. So in this particular video, what I like to do is show you some basics of rear axles, how they kind of work, and some of the ways you can actually rebuild them on your own, like change the bearings, and the mystery around crush collars and how to set up, you know, pinion depth and all of that. Briefly, this isn't going to be a complete tutorial, but just I'm going to take this unit apart, clean it up, put new bearings in it, reseal it, and send it on its way. But in the meantime, I would like to show you how some of the things work. Hopefully you'll like it. Let's get to this. All right, so the first thing I'm going to do is take off this rear end cover. Now, it's hard to see, but there's a lot of tags on these rears, which designate the ratio and the ring and pinion size, and Jaguar had all sorts of different types of little indicators. Now, a lot of the Jaguar ring and pinions are unique to Jaguar. All these Dana 44s, a lot of them have different splines. Well, that came off. All right, so let's look at these tags. BP-L, which is means that it's a power lock rear. Maybe British power lock. I don't know what the B stands for, but the PL stands for power lock. The next one is the ratio. Let's see what you got here. This one's kind of hard to see, but it says 43/13, which if you do the math is 331. If you look on the ring gears on most of these Dana 44 setups, you're going to see that they stamp both the ring gear tooth count and the pinion tooth count. And it says 43/13, which means you got 43 teeth on the ring gear, 13 teeth on the pinion. If you do the math, 43 divided by 13 is 331. So the ratio of this setup here is a 331 axle ratio. We've got caps on either side that hold the carrier section in place. The caps are usually stamped. So what you do is, if you kind of look, you'll see that they've put like a 5 here and an S5. Now on this one over here, you'll notice that it's kind of put sideways. So the S here and the 5 are sideways. And what they do is, this is so you know how to orientate the caps and what side they're on. So this S5 orientation, you can't put this one on this side either this way or this way, because it will not line up with the way this is marked. So they usually put one set of markings horizontal and one set of markings vertical, so you know which caps go where. If you don't have caps that are marked, mark them yourself. But you always want to put the caps back in the same way they came off, because these particular case sections are line bored and line honed with the caps in place, and that's how you have to put them back together. That if you put them together the wrong way, you could end up with some problems. So the next step before we take this off is we're going to flip this thing around and remove the pinion nut on here. And the reason why I'm going to leave everything intact is so I have a little bit leverage to work on getting this nut loose, because sometimes they could be pretty tight. So what I simply do is I put a bolt in here and I put a wrench. Catch the wrench in the bolt like this. When you turn it, it's going to lock up. Okay? This is an 1 1/8 nut. I have a 3/4 drive set. You can actually use an impact gun. It'll probably come right off. Here you go. It's coming off very easy. Now these yokes are sometimes pressed on the pinion and they're drawn in by the nut. You'll get a new nut in a kit. But this one's coming out. You want to inspect to see that the area that the seal rides on is okay, that it's not messed up. This looks fine. keep your caps and bolts together. Now these rears have all sorts of different bearing setups on here. And what I've got to do is I got to order a kit for these things, and I got to make sure I have the right bearings. They have numbers on the races and numbers on the cones. Now what you could do is you could usually put something in here to pry the carrier out. Like this. And then just pop it out. Now what I'm going to do is I'm going to keep everything together, okay? Just like this. Now we've already taken out that pinion yoke, so the pinion will slide right out now. Okay? These bearings actually look fairly good, but we're going to change them. And the ring and pinion looks very nice. It's got good wear on it, good pattern on it. Nothing's busted up, nothing's pitted. It's a beautiful ring and pinion set. So the next thing to do is we're going to take these races out, and I'm going to show you how to take these bearings off the carrier. So the outer pinion, bearing race, and front seal are over here, and you can actually catch the outer edge of the bearing race with these cutouts in the case. They're two cutouts 180 degrees apart. You can get in there with a punch and actually walk the race out. When you punch on the race, you'll actually push the pinion bearing out as well as the seal all in one shot. So there are two pieces, one is over here and one is up over here, 180 degrees apart. Once that's out, we can flip the case around and take the rear pinion bearing race out. All right, so you can see we've got the pinion bearing, the cone of the bearing out, the front seal, and this is called an oil slinger. And the race is still in there. We still got to get another shot at it, get the race out. And there's your race. Now we're going to flip this over and do the other race. So you have the same situation going on in here. You'll have recesses for the inside bearing race in the case on both sides, 180 degrees apart. We're going to knock these out, but you want to be careful because there's a shim behind that race and you don't want to damage the shim. So if you can actually go on the outer edge of the race to get it out, you're probably better because the shim is going to be in that recess there and you don't want to be whacking against that shim. If you've got new shim sets in stock and it's just a simple matter of taking a micrometer and measuring the shim's thickness and duplicating that when you put it back together. So I flipped the housing over on its back, and now what I'm going to do is punch out that inside race and be careful not to damage the shim. Flip it over. There's the shim here. And the race. So pretty much everything is out of this housing. There's some O-rings I'm going to remove that are used to seal the axle half shafts in here. These are probably very dried, and that's what they look like, the O-rings. Not all Dana 44 rears have these O-rings like this in them. These are pretty much specific, I think, to the Jaguars and maybe some of the Corvettes. But I'm going to pull these O-rings out so they don't get damaged in the solvent. They're actually in good shape, just in case I can't find them. So the housing is completely disassembled. All the races are out, seals out, and I'm going to get this thing cleaned up. Next step is to remove the pinion bearing and the carrier bearings. I use a bearing splitter to take off the pinion bearings. Some people use the clamshell tool that I use for the carrier bearings as well, but since I do have a press in the shop, it's pretty easy just to use the bearing splitter. You want to make your nuts as tight as possible so the splitter doesn't slip out of the way. Now, you see these two holes over here? There's a tool that goes on here that has a little bridge that fits with a threaded rod and a puller on top of it. So if you don't have a press and you get one of these bearing splitter setups, you can actually just use that by itself. But the press makes it so easy. So you never want to press directly on the thread. You can use an old socket, put it over it like that. Just press down here. These are very tight sometimes. If they're super tight, they don't come off on a press like this, you may want to actually have to cut the race off. This is tight. And it's moving. So what I like to do is, this gear has been cleaned already and checked for burrs. It's in really good shape. What I like to do is take some sandpaper and just kind of clean up the surface that the bearing was on. Now, some pinions will have the actual shim to set the pinion depth up behind the rear pinion bearing. A lot of 12-bolt Chevys are set up that way. So when removing bearings, you want to, of course, be careful not to damage the shims. Most ring and pinion installation kits will, of course, have new shims in them, so you don't have to worry about it. But sometimes it's a good idea to use your old shim as a base to start from if you're starting from scratch with a new ring and pinion set. With this particular rear, we're going to just put new bearings in it, so there really is no reason for us to change any type of pinion depth with new shims or backlash or anything like that. We're going to just change the bearings and put it back together again. But my idea is to show you a few things once these bearings are together, and a few tricks that I think that'll help you out in assembling rears and to better understand how the rear axle assemblies work. Okay, so we want to press on the new bearing. And of course, it's going to start over here. I use an old bearing race. It's actually a 6308 bearing race, the inner race that fits perfectly on this. You can see it goes all the way down here. It fits really nice and snug, so this works really good. The other is you could try heating the bearing with a hot plate or a heat gun. So why don't we try doing it with the heat gun first and see if that works. It's a lot easier than using a press. If you want to make sure it's seated just a little bit, you can gently tap it. Just to make sure it's seated. While we're at it, I want you to see how bad these raceways are on the carrier. Look how bad the carrier bearings were. They were pretty bad. Noisy, definitely noisy, and obviously the whole thing was going to come apart if this wasn't fixed. You can see right over here this big loss of material. Always change your oil. So now's a good opportunity to explain the differences between pinion bearing preload and the actual torque that's required to tighten the nut over here, okay? There's two different things. When you have a bearing, just like a wheel bearing that's pressed on here like this, okay? We've got this bearing set up on here. The races are in the case. One race is in the back of the case, one race is in the front of the case. Now, just like the wheel bearing, as we tighten this nut, we're going to tighten the bearings, and we're going to preload the bearings to a certain amount of drag, which we call inch-pounds of drag. That's how these are measured, in inch-pounds of drag. If we don't have some way of maintaining that preload between the bearings by using either a spacer to get in here, like this, we're going to have no way of creating a high torque value on the nut to keep it from loosening up. So these collapsible spacers are designed to do both. It's going to take a certain amount of torque on the nut to overcome the spacer and collapse it. That could be 150 foot-pounds to 200 foot-pounds, depending on the rear. And once that spacer is collapsed to a certain height, then the preload of these two bearings will come into effect. So as we first initially put the rear together, we're going to have a very low preload, maybe about 5 inch-pounds of drag. With new bearings, we like to see around 25 to 28 inch-pounds of drag. So then this collapsible spacer will collapse. You can see the difference between the new spacer and the old spacer, the bump in it, how much it's collapsed, okay? And while it's collapsing, it'll maintain a certain breakaway torque then on this nut over here. Now on the other rears, there's two different types of Dana 4s. Let's just put this nut on here. See, there's going to be a certain amount of breakaway torque we're going to have to put on this nut. If it's too loose, the whole rear is going to come apart. So other Dana 44s have a solid spacer. So what you can do is put the solid spacer in here, and the solid spacers usually have some sort of shims like this with a solid tube and some shims that you correct to get your bearing preload, again, of these two bearings. And once that's done, then you just simply lock it down and torque the nut to 200 foot-pounds. But the idea, I guess, of the collapsible spacer was to simply do two things in one operation: create breakaway torque for the nut and maintain the drag needed for the preload on the bearings. Now, when you set up a rear, you don't need to put spacers in here to set up your pinion depth. You can leave your collapsible spacer off and just dial in the correct preload of the bearings, say 28 inch-pounds, then measure your depth over here in the front, in other words, your pinion depth. Once you get that set up at the same preload of the bearings, you'll see a lot of books that always say, change this all the time. If you don't get it right, change the crush collar. Leave the crush collar out. Set your preload of your bearings. That's going to set your drag and everything. So if we're going to set our height of the pinion, let's say at a certain depth with 28 inch-pounds of drag, we can leave the collar off, get that corrected, get our inch-pounds down to where we want, and get our shimming correct for the pinion. And then we just simply take it apart, snap the new collar in, and then duplicate that same amount of torque on these bearings. So again, you don't need a collar on the rear to keep on setting pinion depth. You can leave this off, get your pinion depth set up with your correct preload again, then put the collar in, duplicate the preload, and that'll give you your breakaway torque on the nut. If you measure on the new collar, the total length of this collar as opposed to this new collar is only 40 thousandths longer. So we've only collapsed this collar 40 thousandths to create a breakaway torque on the nut necessary to create the right drag on the pinion bearing and the right load on the nut to keep it from just backing out. What I always do is always put red thread locker on these nuts anyway, and I also put red thread locker on the spline over here to seal it, because oil can leak through the spline. So I always put thread locker on the spline as well. I got this simple bearing clip installation tool. I use it to drive bushings and bearings on a lot of different applications, not necessarily just rear axles. And believe it or not, this particular setup works pretty well in getting the right driver for, like, say, the pinion bearing races. So we can just put it in here and we can see which one works well. And that's not too good. Let's try this one here. We could use that one, drive it in with that. They have different, this is perfect. We'll use this one. Make sure your surfaces are super clean, that the race is going to go against, that there's no burrs on it. And just drive this race in. Nice, huh? All right, so what we're going to do is we're going to put the shims back inside that case. Same way we took them out. Now, oftentimes, the race could cock a little bit. I have a little soft steel punch bar, and I'll kind of just align the race. What you can always do is look on the back side now and see that the shim is fully flush against the race out of those little cutouts. That's how you can inspect it. It's seated properly. And it is. It's totally against that. So what we're going to do is we're going to take the pinion with the rear pinion bearing in place. We're going to slide on the collapsible spacer. We're going to put this whole assembly in the case. Then we're going to take the front pinion bearing. We're going to put that in place. Then we're going to be putting the oil slinger in place like this. This is going to be in the case now. We'll put that new seal in place, and then we're going to put this flange on there. And then what we're going to do is put some sealant on these splines so that no oil can leak past the splines and past the nut and out in the unit. So a lot of people forget doing that. You got to always put sealant on these splines. So I make these spacers with some sliders, and I lay the pinion on top of it. I know it sounds crazy with the collapsible spacer, and I actually lower the housing on top of it like this. That allows me not to have to kind of fumble with things sideways. Then I can kind of put the pinion in there. Just tap it down a bit. All right. I can put the oil slinger in place. Like this. I've taken the seal, I've greased it, and I've also put some sealant on the outer edge of the seal. That's going to go in like this. You can actually use the old carrier bearing race Then you want to take some anaerobic gel and you want to put it in the splines of the flange. That's going to help seal them as well. Going to take your new pinion washer, put it in place, and the new nut, which I also use. This stuff is a thread locker. It works really good. Put it in there like that. We don't want to lock this nut down all the way. We just want to get it going so we could start working the collapsible spacer and taking measurements. All right, so we've got this thing kind of just started. You can see it spins really easy, too easy, right? A little bit loose. And we're going to use this inch-pounds torque wrench. I got a couple of adapters on it, so we can bring it up to a 1/2 inch. And you can see we've got no drag on it at all. Maybe about, going back and forth, maybe about 2.5 inch-pounds of drag. Now, Be careful. We can do this. And keep on checking it. All right, so now that I got a little bit of drag on it, I know this is not enough drag actually to do a measurement yet. But what I will do is I will look at like some of the lettering on the socket and watch the way it moves. And anytime it moves like maybe 1/8 of an inch, I'll stop and check the feel. So now I've got some drag on it. Let's go measure the preload. Right now we're at about almost 10. So another shot may do the trick. All right, so I kept on giving it a couple little bursts here and there. And we want to do is, the spec calls for basically, on these rears, 14 to 19 inch-pounds of drag. So we're going to set it to 0. And we've got roughly around 15. And I'm going to just see if I can give it one little shot to get a little bit tighter. That's perfect. The Dana 44 carrier assembly actually preloads the carrier bearings with shims behind the cones, which is a little bit annoying because if you're going to be setting up a lot of rears, sometimes it's a good idea to get some new carrier bearings, hone out the bore so you can slip these on and off and make your changes. But what I always tell people is that because you're using the same carrier with the same housing, always keep the total height of the shim packs the same. So if you're changing a ring gear, you're going to be putting a new ring and pinion set in, just remember that the total of these shims doesn't have to change. Your total stack height of 100 thousandths should remain no matter how you move it. You should always just keep 100 thousandths. That's an easy way of starting off. If you are putting a new center section in, or carrier assembly, you may want to actually read up on the manufacturer specs as far as where they want the preload to be. And what you usually have to do with that is put that in before you put the pinion in so you can get an idea of the drag and the movement of the assembly before you assemble the whole thing, so that the pinion isn't in place and you can actually check things. It's very simple. Again, if you can see over here, these bearings are in really bad shape. Now I got a tool to take these apart. I've had them for a while, these clamshell pullers, but you can, if you're careful, cut this off, slice the race, wearing safety goggles and wearing thick gloves, cut into the race pretty deep. Usually if you hit it with a chisel, it'll break the race apart and come apart, like I did in my 5-speed overdrive rebuild video with the .80 overdrive sets where we have to cut the bearing races out. So in this particular application, I'm going to use a clamshell puller. I actually sell these, so let's see how that works. Okay, I'm ready to change the carrier bearings because they were shot, and that was one of the reasons why this unit was in for repair. But I just want to touch upon something. You will see a lot of people on the internet using air chisels and cut-off wheels on bearings to take them off these carriers. I've seen people using torches, but I currently use what's called a clamshell puller. It's a universal puller. It's great if you're doing a wide variety of different differential work because it's universal and has several different clamshells for different types of carrier bearings. It works very well, very efficiently, and very fast, and it's a lot less dangerous than using a torch or an air chisel on a bearing. I've actually seen people shatter bearings and actually have pieces of the bearing go deep into their hand and have to have microsurgery for them to be removed. So I don't really recommend using air chisels, but if you have to, or you have to cut the bearing because it just won't come off any other way, my best advice is to you is always wear safety goggles, wear good thick gloves, even protect yourself with maybe a welding suit or something like that. So if something does shatter, you're not going to get cut up and you're not going to be in the hospital for some hand surgery or something. So these clamshell pullers come with a variety of different size clamshells, and each clamshell has 2 different bearing sizes it's machined for. You can see it's a split shell, and you'll see that one side is smaller than the other. If I flip this around like this, you can see that the diameter of one side is different than the other, okay? See that? So they have 2, so basically you have 3 different clamshells, 6 different size bearings they can be used for. And in order to pull these types of bearings off, you actually need to be using the race on them, like this. And this is called a pull bar. You put the pull bar on it like that. Simple as that. And this particular clamshell is the one that we've used for the Dana 44. Now we have to kind of look at, make sure that we're on the right side. We check the way it fits. We see if it fits inside underneath the bearing really good like that. And that's what we want. So we check that first and see how it fits, that it's completely underneath the bearing where we want it. Next thing we do is we put the puller on there. Turn it in so it's just touching the bar. And turn this so that it's just hitting the bearing race. Now when you put this on like this, you want to put it so this screws in and just touches the top of the inside of the clamshell, like that. Now we're locked in tight. Then you have this retaining collar that you put over the whole thing. Lock it in place. And there you go. On the top over here is an 1 7/16" hex socket that you would use. But this is the setup and how it works. It's very simple. Now again, you can cut the race off. You can use an air chisel. But with an impact gun, you can get this thing off in about 3-4 minutes. It's no problem. Now unfortunately, I don't have an impact socket that's an 1 7/16". But I got my heavy duty 3/4 drive set. So I'm working the puller, taking the carrier bearing off this way. Now if you had an impact socket on this baby, you could take these things off very quickly. Now obviously if you were changing shims back and forth, you wouldn't want to be going through this process. So that's why if you're doing a lot of these rears, what I normally do is I have a set of different carrier bearings honed out so they just drop down. There you go, bearings inside here. You want to make sure that these shims stay with the correct bearing and the correct side. If you got to label them, bag them, do what you need to do to keep this thing bagged properly so you don't mix them up. So I hope this doesn't get too confusing. Pinion depth is measured from the center line of the axles to some sort of ground checking surface on the pinion gear itself. Now because the bearing caps, these caps over here, have to split on the center, you could use actually these areas to measure from. Now the Dana 44 nominal checking distance is 2.635. That's the nominal distance for 0. Keep in mind this says a +6 on it, which means that it is basically coming forward 6 thousandths normally than where it should be. So this should be somewhere around 2.630 to 2.6, let's just give it ±1, 31 or 29, okay? So what you can simply do is take a piece of flat ground stock. I buy this at MSC Direct. It's very accurate and pre-hardened. It's 1/4 inch thick. You can lay it across your saddles, which is your center line. Then what you're gonna do is you're gonna take a depth mic. Let's take a depth mic here. And we're gonna just, this is a 2 to 3 inch depth mic. We're gonna lay it on the saddles like this. Push it down hard. And our measurement is 2.880 to 2.881. If I take that measurement and I subtract the thickness, we're going to end up with 2.630, which is pretty much on par where it should be. So this is a pretty good, accurate way of measuring pinion depth. Very simple way to use it, very cheap way. It works very well. I have a wide variety of different pieces of flat ground stock with different lengths because I can go across the saddles this way, depending on where the pinion sits. Pretty easy setup, doesn't cost as much as one of those fancy tools, and actually I think works a lot accurately because we don't have to do gauge checking and adding a bunch of different things to it. 2 pieces, very simple to use. I've been building rears like this for years with no issues at all. I'm making sure I got the orientation correct for the caps. These caps get torqued down to 60 foot-pounds. First, what I do is I just seat them first before I really start applying torque to them. You know, by the way, here's a trick. These paint Sharpies that you can get from Home Depot work really well for checking patterns. And what I like to do here is just do a quick pattern check just to see that it matches the old pattern that was already on the gear, just to double check. So you can see here that this pattern matches the old pattern on the gear. It's good to go. Well, I just want to recap a few things about this video. This video, again, was just a repair video. It wasn't a video on setting up ring and pinions. It was a video on changing pinion bearings and carrier bearings, which a lot of people have to do, and change bearings and change seals. And I just wanted to kind of point out to you a few things. So I want to review a few things about Dana rears in general and shimming. So let's get to it. So now let me go over the checking distance and how we measure Dana 44 rears. Any Dana 44 ring and pinion set, the pinion is going to have a marking on it. It may have a negative number, like a -6, or a positive number, like a +6, or a 0. The 0 is what we call the nominal measurement. And that nominal measurement is 2.635. And that 2.635 inches is the checking distance from some ground portion of the pinion to the center line of the axle assembly. Now, if we have a +6, that means we are going to move the pinion in 6 thousandths towards the center, and we were going to have to subtract from the checking distance. So adding 6 thousandths worth of shims will now bring the checking distance down to 2.629. If we had a negative number, we're going to be moving farther away from the center. So let's say a -6, we're going to now have a checking distance of 2.641. If we had a 0, 2.635 would be your checking distance. So if you happen to be changing a ring and pinion set and your original pinion has a 0 on it and the new pinion has a 0 on it, in theory, you're supposed to leave the same pinion shim in there. You should have the same checking distance. But if you are going to change from a 0 to a -6, then you're going to have to take out 6 thousandths worth of shims. If you're going to go from a 0 to a +6, you're going to have to add 6 thousandths worth of shims. Now, sometimes you might have an original ring and pinion set that has a -4, and now you're going to add a -6 to that, which means you're going to have to subtract 2 thousandths more from your original shim. So it gets a little crazy, and that's why learning math with negative numbers is a good thing. So let's review carrier shimming. If we have left and right bearings, and they have 50 thousandths each under each bearing, that's a total of 100 thousandths. You want to keep that total the same no matter how you move the carrier left and right. So in this example, if we needed to move the carrier from the left over to the right, and we needed to add 10 thousandths to this side, we got to take 10 thousandths off of this side. If you're on this lower example, if we want to go from the right and move it to the left, here what we're going to do is say add 2 thousandths to this side, but subtract 2 thousandths from this side. If you're using your same case and your same differential carrier, there's no reason to change the stack height of the shims. Just always remember that the total of left and right should always be the same, no matter how you move it, this way or this way. Now I didn't have to go put a dial indicator and check backlash because I was simply changing the bearings, and there really is no need to go through the whole process of checking backlash because you want to keep the pattern exactly as it was before. So you really don't want to start moving around stuff. And when I actually put that white paint marker on the ring gear, the pattern was identical to what it was before. So I know that that rear is going to be fine and it's going to be quiet. It was actually just noisy from bad bearings. There are a lot of good tools in the market to actually take carriers out. There's things called rear end spreaders. I know it sounds weird, but I think I have one over here as a matter of fact. Hold on a second. It's a massive piece. All right, so look at this crazy thing here. This looks very medieval, but what you got here is you got dowels that go into the case. And then what happens is you got the screw over here that you kind of jack this thing apart. This thing is fixed into the case and it starts spreading the housing. Your carrier with the ring gear is like right over here, and you just pull this thing up like this once the carrier starts to get loose. The only thing that makes me a little bit worried about using rear end spreaders is that it's cast iron, and cast iron really isn't that stretchable. So I'm always afraid of cracking something or distorting something where it's not going to come back. So as much as you saw me pounding in the carrier with a rubber mallet, you can put one of these things on there if you have it, and then the carrier will drop in and release it and it'll be fine. That's what it looks like. That thing really does look like some torture device. So that was it. Let me know what you think. Please subscribe to my channel, hit the notification button and all that good stuff, and see you soon. Thank you.